A sundog, also known as a parhelion, is a bright spot of light that appears to the left and/or right of the sun, at the same elevation. They are caused by the refraction of sunlight through ice crystals in high, cold cirrus clouds. Essentially, they are a type of halo, an optical phenomenon in the atmosphere. Here's a more detailed explanation. Formation. Sundogs occur when sunlight interacts with hexagonal ice crystals that are oriented horizontally in the atmosphere. These crystals act like prisms, bending and refracting the sunlight, creating the appearance of mock suns. Location. The bright spots typically appear at a 22-degree angle to the sun, on either side or both, and at the same altitude as the sun. Color. Due to the way light refracts through the ice crystals, sundogs often exhibit a reddish hue closest to the sun, with a blue or white tail extending away from the sun. Visibility. Sundogs are most commonly observed when the sun is low on the horizon, such as during sunrise or sunset. They are often seen in cold weather, but can occur anytime when the right cloud conditions are present. Cultural significance. In some cultures, sundogs are seen as a sign of good luck or a harbinger of colder weather. Sundogs, also known as mock suns or parhelia, are optical phenomena that appear as bright spots of light on either side of the sun, typically 22 degrees away. They are formed when sunlight is refracted and reflected by hexagonal ice crystals in the atmosphere, specifically those found in high cirrus or cirrostratus clouds. Here's a more detailed explanation. 1. Ice crystals in the atmosphere. Sundogs are caused by the presence of hexagonal ice crystals in the atmosphere, often in high-altitude clouds like cirrus or cirrostratus clouds. These ice crystals are typically plate-like and horizontally oriented, meaning their flat faces are parallel to the ground. 2. Refraction of sunlight. When sunlight passes through these ice crystals, it is refracted, meaning it bends as it enters and exits the crystal. The hexagonal shape of the crystals and their horizontal orientation cause the light to bend at a specific angle, typically around 22 degrees. 3. Formation of sundogs. As sunlight passes through the ice crystals, it's refracted and dispersed into its constituent colors, similar to how a prism works. This refracted light creates bright spots of light on either side of the sun, which are the sundogs. The colors are usually arranged with red closest to the sun and blue on the outer edge. 4. Factors affecting appearance. Sundogs are most commonly seen when the sun is near the horizon, such as at sunrise or sunset, as sunlight has a better chance of passing through the ice crystals at lower angles. The ice crystals need to be aligned in a specific way for the sundogs to be visible, and their appearance can vary depending on cloud conditions and crystal orientation. Sundogs are more frequently observed in polar climates due to the prevalence of ice crystals in the atmosphere. These crystals, formed in cold, clear air, are essential for the refraction of sunlight that creates the sundog phenomenon. The lower sun angle at sunrise and sunset also increases the likelihood of seeing them in polar regions. Here's why. Ice crystals. Sundogs are formed when sunlight passes through and is refracted by ice crystals, specifically hexagonal plate-shaped crystals, suspended in the atmosphere. Cold temperatures. Polar regions experience consistently cold temperatures, which leads to the formation of ice crystals more frequently than in warmer climates. Clear skies. The cold, dry air in polar regions often allows for clear skies, providing an unobstructed view of the sun and the ice crystals. Lower sun angle. During sunrise and sunset, the sun's angle is lower, allowing sunlight to travel through a greater depth of the atmosphere containing ice crystals, increasing the chances of seeing sundogs. While sundogs can be seen anywhere with the right conditions, the prevalence of ice crystals and the lower sun angles make them a more common sight in polar regions.